Welcome to the Stormsurf video surf forecast for the week starting Sunday, September 6th. First up, we take a look at significant wave heights for the North Pacific Ocean. We see three tropical systems, or at least what was tropical systems. First up, Tropical Storm Jimena, 45-knot winds, northeast of Hawaii, moving basically to the west, and slowly fading out. Of more interest is Typhoon Kilo, winds 90 knots, again, also heading off to the west, but forecast to recurve. And then the remnants of what was Ignacio moving to the north, high pressure over in this area, and it's getting ready to recurve. Winds are pretty minimal, but seas in the 22-foot range. Let's get into the details. First up, Jimena, probably of concern only to Hawaii because of its close proximity. Currently positioned right about here, 45-knot winds. What is that, about 450 miles northeast of Hilo, Hawaii, and getting ready to make a turn to the west. And as you can see here, winds are to slowly fade. Nevertheless, swell is in the water, continuing to hit northeast-facing shores of the Hawaiian Islands, but is expected to slowly peter out. And as the eye, or what is left of the eye of this, what will be a depression, moves west of any point of the islands, then swell should drop off rather dramatically. Of more interest is the track of Typhoon Kilo, currently north of Wake, about 300 nautical miles, and moving on a west-northwest track, forecast to build some to 100 knots 2 days from now, so that's on Tuesday, roughly in this area. It was forecast to actually get up to 100, 125 knots days ago in earlier forecasts, but not looking nearly as strong now. And the good news is, it is forecast even now per the official Hurricane Tracking Center to make a turn to the north and to the northeast, but by then winds are only going to be at tropical storm force. Let's do a quick look at the GFS model. And here we go. We see all three systems here, and here's Kilo. We're just going to really focus on Kilo, doing exactly what the official forecast track says. And then here we go into Thursday. It tries to make that turn to the northeast. Notice high pressure here. And we had thought it might punch a hole in that, but it appears to not be the case. Notice high pressure here, 1028 millibars, pretty much locking down the entire North Pacific. Just shreds this guy. We see some activity here, 180 hours out, but again, there's a big trough here, and we'll get into that in a second. We're not sure that a whole lot is really going to happen from this. So for now, the tropical systems, for the most part, are only of interest to Hawaii, and only when they're in close proximity there. And then one other system down here, you can hardly see it. This is Tropical Storm Linda, forecast to take a pretty favorable track relative to Southern California, going north-northwest, clearly in close proximity to Southern California. This would be about 650, 700 nautical miles south. Winds forecast to get to about 90 knots or so. Maybe a Cat 2 hurricane, good enough to push some swell in. The problem is there's going to be, and this is on Wednesday, so maybe by Thursday or Friday swell would arrive in this area, and by then the southern hemi swell that is currently hitting this area will dissipate. So this would be a nice little backup bit of energy to get Southern California just about into the weekend. And since we're out of here, let's take a quick look at the North Pacific jet stream. Jet stream winds up about 30,000 feet or so, help support the formation of storms, and when those storms do form, help direct their track. What we're really looking for is El Nino influence. How strong is the jet? Where is it positioned? Because that will tell us whether it has the opportunity to tap some of this tropical energy, or actually it's the other way around. Will the tropical systems have opportunity to tap the jet stream, get supercharged, go extra tropical, and form a monster storm? This is what we would be looking for if a strong El Nino were in play, which supposedly it is, and to create large, long-period swell in the September time frame. That's not to say it can't happen in October and November, and it's much more likely in that time frame. But when you have, really, we're using 97 as the guideline. Massive extratropical typhoon swell was generated late in September from a system that made it right about to the date line, supercharged by a very intense jet stream early in the year. So anyway, let's run through this, take a look. So the jet stream isn't looking horribly bad at this moment in time, much better than it was last week. There's still a bit of a ridge here, but it's more just a gradual ridge, not some sort of a ridiculously resilient ridge as it has been labeled as of late. Anyway, so the jet sort of meanders along here just south of the Aleutians, getting some winds in it, and actually not bad for this time of year, 140, 150 knots, meandering across. And then this is the interesting part. Come later in the week, it's actually supposed to dive pretty far south and start carving out a good trough here over the date line and continuing into Saturday or so, and then it kind of gets pinched off, tapping some of the tropical energy here, but notice there's not a whole lot of wind energy with it by the time it does that, and we'll just roll this out. And the sense is from looking at this that it'll just get cut off and winds will start ripping across here again, and whatever was down here enhanced by tropical activity will just basically get cut off from the energy flow and not do a whole lot. But you never know. The good news is at least the jet is looking reasonably strong. And finally, let's take a look at significant wave heights for the North Pacific Ocean for the next week. And of course, like we said before, Kilo, Jimena, remnants of Ignacio. Ignacio here is what we're kind of watching for the immediate because it gets caught by the jet and actually tries to get it together. 22-foot seas over just a tiny area, fading to 20-foot seas on Tuesday and bound for British Columbia. The thought is that might be good for sideband swell into Central California, maybe 3 feet at 12 seconds or so, maybe 13 seconds if you're lucky. And then, of course, we have Linda down here. We can watch her track as she barrels north, not particularly large compared to Kilo, but still in the Southern California swell window and in close proximity into Thursday, fading out. And of course we have Jimena still hanging around here even by Friday of next week, but just fading out. Really our eyes here on what Kilo does, but you notice Kilo, again, high pressure this area, pushing whatever swell activity it has. So there's a gradient, you know, this system has a counterclockwise circulation, high pressure here. With clockwise circulation, all the winds get pushed basically north, nothing towards our forecast area, and this system just kind of is a fish storm bound. You know, if you're in Kamchatka, yes. Bering Sea, fishing interest there, might want to keep an eye out for that. The one possibility is if and when the jet, notice it's diving down here at this time, sort of keeping an eye on this, sort of keeping maybe something will coagulate here in the Gulf of Alaska. But again, this is a week out. Don't believe any of this. We typically don't believe models more about 3 or 4 days out, but a little bit of a tease, something to look forward to. And by this time, we're in the middle of September. Let's go take a quick look at the South Pacific. And we're just going right to the wave models for the South Pacific Ocean here. Suffice it to say, there's a gale here, 35-knot north winds, generating 22, 23-foot seas, one pocket of 24-foot seas. The interesting part here is it's aimed, all the fetch is aimed well to the north. The low is doing this sort of a circulation. This certainly will generate swell for Tahiti, certainly for Hawaii, but the problem is let's say 23-foot seas. That's good for maybe 13 or 14 seconds period. That period doesn't have really enough energy. It will decay as it works its way north. Still, swell for these locations. U.S. West Coast, not so much. Yeah, probably will end up being some swell. We typically undercall these sort of events, but we're not expecting a whole lot. Let's roll this out. And as you see, it does hang around for a little bit into Monday and then fades out basically. And after that, not a whole lot going on. You definitely get the sense there's blocking high pressure in the upper atmosphere here, driving the jet well to the south. And we continue to see little bits of, basically this would be cut off low activity. Just not a whole lot going on. Something here perhaps relative to Tahiti long term. But for the most part, now there is swell in the water for Southern California. That's to continue for well into the work week, and also Hawaii. But the bulk of it is pretty much happening now or within the next 24 hours. And then it will be a slow and steady decline, but Southern Hemi swell is swell, take it no matter what, because there isn't a whole lot going on in the Northern Hemi at the moment. Now let's move on. Let's take a look at long-term predictors, what's going on. Of course, all the talk is about El Nino, and all of it is justified. Things are looking much, much better than what we've seen the past month or so. So let's dive in deep. First up, surface level winds. Surface level winds or wind anomalies in the West Pacific generate Kelvin waves. Kelvin waves migrate under the equator to the east, erupt around the Galapagos, create a warm pool at the ocean surface, which then gets caught by trades, advects off to the west, and creates a bigger warm pool covering more area, and that ultimately in the fall and winter months helps enhance the jet stream in the North Pacific and helps support stronger and longer lasting and more frequent storms in the dateline to western Gulf of Alaska into the Gulf of Alaska, which of course generates a large surf for the U.S. West Coast and Hawaii, and also can provide precipitation, which is much needed along the California coast. So currently, we're looking at data from buoys anchored on the ocean surface along the equator, West Pacific here, East Pacific here. We see actual westerly winds in the moderate strength, mainly north of what we call the Kelvin wave generation area. We'll get into that in a minute, but actual westerly winds are a very good sign. Down here is the actual wind anomalies. Differences is normal for this time of year, and we see moderate, not quite strong, maybe strong up here to the north, but in the Kelvin wave generation area, moderate westerly winds working their way almost even past Hawaii, almost to a point south of California. This is very good. We are purposely ignoring the water temperature issue right now because we're talking about winds. Now here's another way to look at it. Here's the Kelvin wave generation area. We do it 3 degrees north and south of the equator. Coriolis effect, once you start moving off that too much, maybe, most folks say 5 degrees, which is fair enough. But what we're interested in here is this long stretch of westerly winds. I mean, this covers the entire Kelvin wave generation area, but it's displaced to the north. We would love to call this a westerly wind burst and say major amounts of warm water are going to get pushed to the east, but we have doubts because of how far north it is and whether it would actually form a Kelvin wave. It might be too far north and just not really make a true Kelvin wave per se, but we'll leave the door open just in case. But we notice winds here per the analysis image up to 22 knots. That's very significant at least in one pocket here, and in generally in the 12 to 14 knot range. So something to keep an eye on. In the Kelvin wave generation area proper, effectively no winds, no trades. Yes, they're coming out of the south, but there's certainly no easterly winds. This has been typical. This is what happens when you get a El Nino base state, we call it. That is, when El Nino you have a mature El Nino, it's taking over. Normal trades in this area get suppressed. You end up with westerly anomalies. Just a lack of trades is enough to get warm water that's in this area moving off to the east, and that's exactly what we want to see. Here's another way to look at this, going back in time. Notice here, 5 south to 5 north. This is the traditional Kelvin wave generation area monitoring. 850 millibar winds. These are actually up about 4,000 feet, but are a good proxy for what's down at the surface. And there's a good amount of data that's used at the 850 millibar level going back about 30 years to use as a baseline to compare what we have today versus what is normal. The reds and yellows, of course, are westerly anomalies. The darker or the more into the purple you are, it actually is not just anomalies, that is deviations from normal for this time of year, but actual westerly winds on the ocean surface in the Kelvin wave generation area, which runs roughly about here to here going down. Anyway, going back in time. So here we are right now, westerly winds in play. This chart, a little interesting, suggests perhaps some weakness in the westerly wind pattern. Just about to the dateline for a couple of days, and then it comes back. But notice, just not a really robust westerly wind pattern, just the same. Westerly anomalies, that's all we need, just continuous westerly winds. Though we really want to see a good raging westerly wind burst, just so we get one more big Kelvin wave out of this El Nino cycle. And here's the same chart, again going back in time, but what it overlays is the MJO, Madden-Julian Oscillation, and this back in the late June, early July timeframe, we had an active phase of the MJO, also enhanced by these little red squares, equatorial Rossby wave, made very, very strong westerly winds. Not just anomaly, but westerly winds working their way across the Kelvin wave generation area. And then notice other little pockets of enhanced westerly winds, if not, or at least anomalies, supported by other equatorial Rossby wave activity. And then the blue here is the actual El Nino base state. Here is the forecast. Now, it suggests the El Nino base state is to weaken. We don't believe that at all, and we'll show you why in a minute. But it also suggests pretty much the same. That little break here in westerly winds. Now notice here, this is in weeks instead of days. Not breaking westerly winds, just weakening of westerly anomalies. And then they continue on through into October. And here's yet another version of the same chart, but goes out more in time. And again, this is reversed now. So this is the past. Notice westerly wind bursts, certainly that one in end of June, July. Bits of other activity. These are actually westerly winds too. Now, per this model, and again, this is a reach, we're talking into October, strong westerly winds forecast on the surface. But here's the interesting part, and not unusual. Notice that the core of the westerly winds start moving to the east, and this is what one would expect during a mature El Nino as you get into the November time frame. That is, and also notice here, these are easterly anomalies. This is all over the maritime continent north of Australia, and what you get basically is this sort of inactive phase over the very far west Pacific. It looks like the inactive phase of the MJO. Active phase over the date line moving south of Hawaii. Westerly winds in it. Really, it's not MJO at all. It's completely El Nino related. This is a classic sign of a major El Nino and a strong one, and working its way into the mature state. Okay? Now, here we go. Again, you can see the big active phase of the MJO that occurred back in the July timeframe, and westerly winds associated with that. Theoretically, we're in this inactive phase right here, but we don't really buy that. It's more, this is just a case of the easterly anomalies, the mature El Nino state, if you will. But anyway, the model is continuing to predict some sort of a active phase of the MJO in the late September, October timeframe, making very strong westerly winds. Not sure if we really buy it or not, but the idea is nice, tantalizing, we'll go with it. Also, let's take a look and examine equatorial Rossby waves, because when they interact with the mature El Nino base state, they tend to enhance winds. So theoretically, there's a little bit of that going on right now, and Rossby waves move from east to west over time. A little bit of enhancement forecast in this big wind burst here, along with El Nino. We suspect if these winds develop, it's not so much MJO related, it's just the mature phase of, here you go, in fact, we'll show it this way. The mature phase of what they call it the low pass, or the El Nino base state. This is typically when El Nino would be maxing out. It's right in the November to December time frame. To see lots of westerly winds in this area would not be surprising at all. So basically, everything's unchanged from last week, still looking very solid and most impressive indeed. Let's go take a look at subsurface configuration, water temperatures. Okay, we've seen this chart before. West Pacific here, East Pacific here, going down depth on the equator, just a couple of degrees either side, 2 north to 2 south on the equator. It is a profile of water temperatures at depth. Of course, these are the buoy anchors for the TAO buoy array, sensors on those anchor lines helping to give us data to know what's going on. Notice a couple of missing sensors here. It should be good to see them because we suspect something more is going on than what this picture indicates. Anyway, warm water. 30 degrees, 29, 28 degrees, and what we want to see is this isotherm line start working its way off to the east. We suspect it is probably a bit more to the east than what this picture depicts, but either way, so this is the warm water from the West Pacific that we want to see moving east. It is not so much, though, actual water temperatures. It is the anomalies, differences in normal for this time of the year, for this location, that you can use to see Kelvin wave development. Clearly, we see a massive Kelvin wave here, 8-degree anomalies. I mean, this really is at 8-degree anomalies off in the East Pacific, down at depth, down about 80 meters or so, and working its way to the east. We've been talking about this for a while. We are starting to see some signs that this Kelvin wave. Notice one of the buoy anchor arrays here, or sensor arrays, is out, but we suspect this water is working its way well off towards the Galapagos. We have another view of it right here. You can see, again, 8-degree anomalies, or 7-degree at least here. Very large area. This is the other cool part of this one, is you can see downwelling warm water here. This is as of August 31st. Remember, we were talking about westerly winds here. They've been non-stop for months now. They are still blowing to date. Warm water falling to depth, feeding this massive pool here, a reservoir, and that is expected to start working its way up to the surface. The Galapagos are right off about here, and Ecuador is right off about here. This is all moving to the east. Notice this one little pocket here. It's actually warmed up from the last image 5 days ago and continues to warm, but also notice you can see little hints of very warm water starting to touch the surface here, and we suspect that this Kelvin wave is actually a bit further along than what this image or the image above it depicts. Remember that one of the buoy arrays is out here, and we'll show you about that in a minute. The other really impressive thing here, upper ocean heat anomalies. You can, again, go back in time. Kelvin wave. The oranges and the reds are hot water, cooler water here. One Kelvin wave last October. Actually, there was another one even before that. Then we got into this year, and look at this. This is very similar to the 97 event. It was just boom, boom, boom. Kelvin wave, very warm. Another Kelvin wave in the impacting the Galapagos over here in the June time frame. This is the massive Kelvin wave, largest of all. Certainly a historically large and strong Kelvin wave working its way. If you can literally draw a line right through here, working its way off to the east. The Ecuador would be here, the Galapagos would be here. Here is that sort of cool blocking pool that we saw. Notice here, it's very faint, but it's little by little disappearing, and as that disappears, we expect all this warm water to fill up in there and start gurgling up at the surface. So, the point being, the underwater profile, the Kelvin wave situation is just astounding. This Kelvin wave, when it hits, we're expecting it to hit. So the peak of the westerly winds that generated it were on about the 4th of July. Typically, just a rough rule of thumb for a normal Kelvin wave moving at normal speeds, takes about 3 months before it starts. When you have the peak of the winds here, it takes about 3 months for the peak of the warming to hit the Galapagos. Then what you'd also expect is about another month, if not more, for that warm water to start working its back into the Nino 3.4 region, which would be more 170 to 120, so in here, and at the surface, though, and that's really what feeds the jet stream. So, assuming this all peaks out on, let's say, October 4th, it won't be till November 4th or later till it really starts getting at the right position to start feeding the jet stream. The jet stream will probably take another month to react after that, so we're talking in the December timeframe or so, and you're talking classic El Nino timing there. So let's take a look at the surface and see what's going on. We know there is a massive Kelvin wave building right under here, but already at the surface we've had 2 prior Kelvin waves. They have gurgled up in this area here near the Galapagos and then gotten caught. That warm water has gotten caught by trade winds, pushed off to the west here, and you can see much warming over from the date line basically the whole way back to the Galapagos. Reasonably warm in here, and actually let's go back. We're just going to go back to maybe a week or so ago. Definitely looking better. Here we go, back in time. Definitely looking more organized back here than it was then, and we'll go back even a couple weeks. The signature is definitely, since 8/17, continuing to look much stronger than it was. And of course we have to do this, compare it to the 97 El Nino because, well, it just wouldn't be right if we didn't do that. So here we go. Now, the picture's a little bit different, but you can see there really is no comparison. Look at the amount of warming, and the scale's exactly the same. This is from the same time frame in 97. Massive warming here in the Nino 1.2 region right here. But here is the interesting part. The Nino 3.4 region, which starts at 120, basically south of California, on out to the date line. Look at that there. Now let's go and take a look at this here. And this here suggests there is considerably more warming out in this region than there was back in 97. So back and forth, back and forth. So the point being, the core of the 97 El Nino was really kind of a, what'd you call it, an East Pacific warm core, whereas this one, at least at this point in time, most of the warming, yeah, there's warming over here, but what's really interesting is the warming out here, the extent of the warming. In the central Nino 3.4 region. So this is not, certainly no one would say this is a Modoki El Nino because there's plenty of warming here too. But the extent of the coverage out this way is actually more so than in 97. And temperatures in this region, 5 degrees north and south of the equator, you put a box right here and measure it. Temperatures right now for this El Nino are the same, if not a little bit higher, and one can debate the details of it, but basically equivalent, if not slightly more, than what was going on in the 97 El Nino. And the 97 El Nino was the strongest El Nino ever. So this is pretty impressive, something to consider. We're not dealing with just any old El Nino. We're dealing with what could theoretically be a historically strong El Nino. They label it a super El Nino. Now there's new higher resolution data available. We prefer this. We show the other chart, the low res data, because it gives us some historical context. We can compare it to 97. But this is what's really interesting, and this is updated pretty much daily. The pockets here, these are 5 degree or warmer pockets. These have just started showing up in the past 5 days here, here, and here. This is when we say we think the new Kelvin wave is erupting. These are why, because none of this was here before. In fact, temperatures were pretty darn moderate and modest in this area. Now much warming is occurring. This is getting us excited because what this means is all these warm temperatures will start working their way off to the west and warming what is already a historically warm Nino 3.4 index even more. Good sign. And of course it also gives us some hints and tells us that the massive Kelvin wave is starting to erupt. The interesting part is it's not erupting so much here along the coast, but it's doing it out here. Okay, and we're not exactly sure why, but every El Nino is different. They each have their own character, and this El Nino seems, at least for the moment, to be not so much like the 97 El Nino that was really just jam-packed here in up against the Central America and South America coast, but seems to be more focused in this area here, which is not a bad thing. It's just different. We suspect what that would mean is ultimately the peak effect of the jet stream would displace, instead of having maybe the jet stream just blasting into California, most of the activity might be out more in here, and that would actually be a good thing from a surf perspective because it would give the swell a bit of a chance to radiate away from the storms that make it as it worked into the U.S. West Coast. Hawaii, theoretically, could be in for a stormier picture. Still, given the magnitude of what is going on right now, rain is certainly a very likely higher than normal rainfall would be expected for the U.S. West Coast. And zooming in yet closer, high-resolution data, you can see here 4 or 5 degree anomalies developing here along northern Peru. Also off here just a bit west of the Galapagos. The Galapagos are here. And warming, the point being here, warming is building over this entire region. We just about have 2.25 anomalies covering this entire region here, and that's exactly what we want to see. There has been a pause here. Remember, we talked about cooler waters in this area. It was getting kind of depressing almost mid-August there because what was very warming, and here we are back in July, which is just looking very impressive. It all died out, and now we're on the rebuild. Here's where we are. So we're not quite where we were in July up along the coast here, but the point being, warm water is building again. Very good sign. And also, warm water. Here's these two warm pockets we saw in the broader view, again, at 4 or 5 degree anomalies, working their way off to the west. This little gap here, we've been watching that. It was actually filled in a day or two ago. It's broken up a little bit. We really, we're into the fine details here. To be a complete snob, we want to say we want 2.25 degree anomalies the whole way out here, running off the picture. That would be what would get us our maximum Nino 3.4 index values. And the more coverage these anomalies had, it's really, we want to fill the box down to 5 south and 5 north. We're not doing bad. This would be probably the weakest spot right here. But with the new Kelvin wave starting to erupt, and we're only at the very beginning of it. We expect to see much warmer temperatures in this area, or at least much larger coverage of these deep, warm waters. That will only work its way off to the west, certainly fill this gap, and we should be in very good position about a month from now. And yet one more picture. Over the past 7 days, this shows the trend, where things have gotten hotter, where they've gotten cooler. We can certainly see warm water building in here. Also, this is nice to see warm water building off of Peru. Not sure. This certainly is related to the Kelvin wave. The rest of this, we think probably not so much. This cooling here is related to a Typhoon Kilo, just basically mixing up the ocean surface, making things cooler, of course. And then you have Jimena here, and a previous Ignacio off here has stirred up and cooled things down a bit. But in general, the trend is looking very good. And then finally back to this chart, again, actual surface temperatures. Notice 30-degree actual temperatures here. Cooler typically in the west because of trades, in the east here, because of trades. They create upwelling, but that upwelling or the temperature difference backs off as more warm water works its way into this area. It is the anomalies from differences from normal here, and this panel has upgraded significantly in the past couple days, clearly now indicating 2-degree anomalies along the equator, pretty much like we've seen in other, but now a pocket of 3-degree anomalies here at about 110 west, so things are only getting warmer. All right, so we've talked about west winds or west anomalies in the West Pacific, creating Kelvin waves. We've examined the massive Kelvin wave getting ready and starting to erupt in the East Pacific, Equatorial Pacific. We've seen the effects of previous Kelvin waves and the warm water that it's created migrating its way across the Equatorial Pacific back to the west. Now the final part is, what is the effect of those warm waters on the atmosphere? We want to see changes in the atmosphere because all this could happen, but if we don't see the atmosphere responding in kind, then that won't do anything for our winter storm production in the North Pacific. So, Southern Oscillation Index, difference in pressure between Darwin, Australia and Tahiti. Negative numbers represent at least the active phase of the MJO, if not developing El Nino base state. Clearly, we have a long run here. Here's a month. We've had numbers negative, fairly solidly negative for a long time. We've had a little bit of a dip lately where it backed off, but now we're back down to minus 17. 30-day running average, minus 14.3. The peak of it was up in here somewhere, minus 20.95. So we've lost a little bit in the 30-day range, but the 90-day average is now at a new record, minus 15.52. When this gets down to minus 18, at least this is our benchmark. When it says minus 18, we know we're in major El Nino territory. All data suggests we are headed in that direction because the 30-day average has been in the minus 18 to 20 for, a long time, and we expect it to continue to drop here at some point. So 90 days worth of data, minus 18 is not unreasonable, let's say in the next couple of weeks or a month. Here's the 30-day average graph. We've shown this before back in 2013. Here's your positive numbers, La Nina. The beginning of the turn, we suspect this was the turn from the, we'll call it the inactive or the cool phase of the Pacific Decadal Oscillation to the warm active phase. Of course, we had a sort of a false start there in 2014, but now we're in 2015. Numbers have been negative. You draw a line through this, it's all going down. Yes, you get your little ups and downs here, but the pattern has been towards the negative. This is exactly how we want to see it. Yet another similar index, that is the difference in rainfall north of Australia versus over what we'll call basically the Nino 3.4 region. The more rainfall here and the drier it is over here, that suggests that the atmosphere is coupled with the El Nino base state. You want to see precipitation over top of the warm water. Warm water allows more evaporation in the atmosphere, which creates more precipitation. And over here, you basically get high pressure locked. So basically, you get high pressure locked over Australia. Things get very dry. You get low pressure north of Tahiti. That's what drives the Southern Oscillation Index, but that also drives this wet pattern. The point being, there is an index to measure that. Currently, it is at 2.01. Historically speaking, here you go. The 82-83 El Nino was a 2.2 at its peak. The 97 El Nino was, let's say, a 2.85. We're at 2.01, and we're not even at the peak of El Nino. So already we're in very rarefied air. No other El Nino, you can look at the chart here, no other El Nino other than the 82-83 El Nino, the 92 did not reach a 2, or just barely if it did. We've actually exceeded that 2 earlier, about a month ago, and then nothing since then. So we are in rare company here per this index. A little bit more conservative index, if you will, recently updated, the multivariable ENSO index, MEI. This compares, it's not only like pressure and precipitation and wind, it's a whole host of variables mashed together to get an index to compare holistically our current El Nino compared to other El Ninos. And here are the top big El Ninos. Of course, the 82-83 El Nino, the 97, but we'll just do it. Here is the 97 El Nino. Here's the 82-83 El Nino. Here is the current standing of the 2015 El Nino. Almost dead midpoint between the 82-83 and the 97 El Nino. And there are only 2 super El Ninos in recent history that, you know, one can reliably measure. And this one, this year, is in company with those. Now, still, to be a super El Nino, it needs to get up here into the 3 standard deviation. We're at, was it like 2.28, I believe. We'll go look at the number in a second. So we still have a little ways to go to get up here. But again, with the Kelvin wave that's about to erupt, we certainly believe that about 2 months from now, we'll be well, if we're not at 3, we'll be darn close to it. And again, in company of the 2 strongest El Ninos in recent history. The actual value here, it was 2.37, up by a third, almost a fourth of a standard deviation. So, again, very good shape. And finally, one more bit of data, a projection for how warm will water temperatures get in the Nino 3.4 region. That is what matters the most. Here's the conservative view from the CFS version 2 forecast. I mean, here we are, we're at, and we got to show you actual water temperatures here in a second, but basically we're in the 1.8 range right now. This model says 2 degrees max. We don't believe that for a second. There is a less conservative version that says this has gone down significantly. Actually, it's saying 2.8 degrees. I would say that's probably closer to where we're going to end up. Let's go take a look at what's actually going on. So here we go. Water temperatures in the Nino 1.2 region. This is the area right up there by the Galapagos and Ecuador. Still muddling along. The Kelvin waves trying, you know, here was where it bottomed out when that was, about mid-August or so. Temperatures are working their way up. We expect these numbers to go up considerably at 1.66. They were up at 3 degrees, 3 different peaks in the mid-July time frame, and we would not be surprised to see that occur again. But again, that's not what defines El Nino. It's out in the Nino 3.4 region. Temperatures there at 1.845, basically 1.9 degrees. We had a peak here up in about the 2.2 or so late August. We expect these numbers to start working their way up. This sort of downfall, I think, is that little gap that we saw out there about south of Hawaii, effectively. But we're not concerned about this at all. With that next Kelvin wave erupting, these numbers should be going up. So to wrap things up for right now, El Nino progressing, major Kelvin wave getting ready to erupt in the Ecuador Galapagos area, already starting to show some signs and building by each day. It's a slow moving train, but it is definitely going to happen. There is way too much warm water to ever think that this is not going to happen. And more westerly anomalies building, and more forecast to get stronger, so we expect more warm water to be falling into the pipe. We're already at what one would call a strong El Nino status as of right now, with water temperatures up in the 1.8, 1.9 range. Only going to go up from here. The point being, this coming fall and winter is looking like a very good season. or high probability for large surf in Hawaii, the U.S. West Coast, and surrounding areas. So prepare accordingly. In the meantime, another sign of that clearly is 3 tropical systems basically all around Hawaii. They've been there for a week. Kilo working its way off to the west, going to do some recurve, probably not do a whole lot, but we expect, if the models are even close to right, in the next couple of weeks, the Gulf of Alaska should start opening for business. And though we don't see a whole lot coming from the southern hemisphere, that's just going to be sort of ancient history as our focus turns to the Gulf of Alaska, and it will probably be there for this next 6 months or more. In the meantime, southern hemi swell in the water. Get it, have fun, keep yourself in shape, stay tuned up, and from here, it's all upward is the guess. So we'll do this again next week, same time, same channel. Go get some surf, have a good time, and be safe.